I'm sure you must have heard of the word perfect square. They are simply numbers whose square roots are whole numbers, or numbers that can be written as the square of a whole number. For instance, 16 is the square of 4. This means that the square root of 16 is 4. You can find other perfect squares like 4, 9, 81, and so on. Interestingly, expressions can also be written as perfect squares. An example is x plus 2 all raised to the power of 2 because it is written as the square of an expression, which happens to be x plus 2 in this case. Hence, completing the square is simply an attempt at calculating what must be added to a given expression in order to make it a perfect square. This is done by first making sure that the coefficient of the quadratic term is equal to 1. At this point, let's take a look at two possibilities. First, we can have a case whereby the coefficient of the quadratic term is 1, like in x squared minus 2x. We can also have a case where the coefficient is not 1, like in 3x squared plus 5x. Whenever this happens, we simply factor out 3 to get 3 into brackets x squared plus 5 over 3x. For this lesson, we will focus on the first case. Once the coefficient is 1, we take the value of the linear term, divide it by 2, and then square the result. Looking at one of our earlier examples, the linear term is minus 2. Hence, we have minus 2 divided by 2, which gives minus 1. Therefore, we will have minus 1 raised to the power of 2. So minus 1 squared is equal to plus 1. And this is what must be added to make x squared minus 2x a perfect square. In another lesson, we will treat questions and also factorize the resulting perfect squares. Remember, in this lesson, we started with the definition of perfect squares. We also learned that for an expression to be written as a perfect square, we must first make sure that the coefficient of the quadratic term is 1. Then, the coefficient of the linear term should be divided by 2, raised to the power of 2, and added to the expression. Bye for now.